All right, we are live. So, what we are going to do today is review the design of our 3D printed MetaQuest 3 desk mount. Um, we printed it, and I am very happy to say that everything worked on the first try. Uh, Worked is a term I'll use loosely. Um, I think it does what I intended it to do, but it's not optimal. There's some things after actually making a physical part that I want to improve. So we're going to improve on our improvements here. Um, I can, let me see. I have it set up on my desk currently. Let me see if I can kind of pull this off and show you how it all ended up coming out. Don't mind me. Don't mind me. I'm just pulling this off my desk. All right. Cool. So here is our final. Let's try to get this to not get cut off. Here's our bracket and the arms. As you can see, we got the screws threaded in um, to our bracket, and we did a good job with our thread design. Shockingly, so the threads are pretty tight in there. There's you can see there's maybe you can see that. Hold on, getting cut off here. Maybe you can see there's a tiny bit of wobble in the screw threads, which are good because these are 3D printed. I care more about the fact that they actually engage than them being like perfectly uh, like line to line throughout the entire length of the screw. So we can screw this in and out. It does what we intended to. One thing that I would definitely like to improve is that the foot of our bracket mount here um, does not grab the ball the way I intended to, because right now it kind of just like loosely sits there and it will fall off. So I kind of wanted this to almost like snap into place and grab that ball. So after I thread the ball or the screw into the bracket, I could take this foot and just snap it on top of the ball on top of the um, screw there. So we'll improve that, make sure that that can engage properly. But I'm really happy with how the rest of this came out. Um, so the controllers slot right in. Uh, and I've been taking these safety uh, straps here and just looping them around one of these fingers. You can see it kind of it grabs this perfectly, holds it nicely in place. The reason why I leave the safety straps on there is if in case it ever falls off, we have a redundant mechanism to make sure that this thing doesn't fall on the floor and get damaged. Um, so that's great. Another great thing is that our Quest 3 actually really nicely mounts to uh, this surface here as I had intended. And when you, let me just throw this on here real quick. When you install the strap and then place the Quest 3 on there, it's not going to do it right now, obviously, because I'm trying to show you, but boom. So this is actually like pretty stable. You can shake this around. I gave my desk the old shake test before and it stayed in place. So when everything's mounted on the desk, this does exactly what I intended it to do, which is lovely. So let's see if I can get everything set up the way it should be set up in frame. So that's exactly how this is how I wanted this to look. So Quest 3 sits in between the controllers. and this all mounts to my desk using this C-clamp. So main takeaway, we did it. Did at least what I intended to do. And we have the geometry of the Quest mount, the geometry of the controller mounts I'm pretty happy with. I actually don't think I'm going to change that at all. But there are some issues. There are some issues, as with like any design. We got it on the first try, and I could leave it as is, but I'm an engineer, and I'm not going to be happy until this is perfect. It's the downfall of engineers. So, one thing, the biggest thing that I want to improve is the fact that when you start to clamp this screw down, because we have a lot of distance here, this is like 4 inches, right? And the force is being applied between the desk and the foot. So when I start to clamp that down and apply load through this screw, it actually takes this whole thing, kind of pulls it apart, and then you'll see the screw starts kind of walking itself out. And the foot, it's not going to fall off the desk. The foot still holds it well. But I can't really like clamp this thing down the way I want. It's not going to fall off again, but I'd like some better engagement and like feedback to the user so that when I screw this in and clamp it in place, there's like I can give this thing a solid shake and it won't translate or rotate around this foot at all. So there's probably one really quick easy way to fix that, and I don't know if it's going to be something that I despise or not, but basically, instead of making this distance here shorter, this height shorter, what we can do is just add some meat to the design. We can just add some material right through here, and I'm going to avoid doing it on the top, but just because this is where the desk should be captured here. So let's go ahead and do that. So what the intent of this is that this little L here won't open itself up as we apply load through the screw. The same force is going to end up going through the top of L here. So we will need to probably come up with a nice solution. But I'm kind of happy with how the Quest 3 sits relative to the bracket. So we're going to have to maybe just beef all of this up a little bit. Or maybe we just increase the infill on our print. That's another option. So first things first, let's see if we make a design improvement here. Or if we change this geometry, let's see how it works, how it looks. So if I recall correctly, yeah, how did I do this here? So I took that piece, took this piece. One really stupid, easy way to do this is just to add a fillet here with a really large radius. Let's see what that looks like. Yeah, not awful. Not awful. But, we can even go bigger. We can go bigger. Let's do like a 1.5. Oh, that was a little too big. So now it should be, I think it's probably running into the threads there. Still too big. 1.2. I mean, I kind of hate that. I kind of hate that. So I think we have to go to option number 2, which is we can decrease this distance here. And the first thing we can kind of do is just edit this feature. And again, assuming that I did all of my relations correctly. Oops, I don't know how to type today. 2.5. Assuming I did all my relations correctly, this should not break everything. And it doesn't. So we were good engineers, for once. So this change should really dramatically. So basically, if we want to go into kind of the math, science, engineering as to why this is a problem, when you apply a load axially through this screw, you are applying a force, and we'll call this the y-axis, down this way, that's creating a moment, which is basically a torque, at this point right here. Let me point my finger in the right place. At this point right here. So if our moment around this axis is dependent on distance and force, so that's why like the units for torque are foot-pounds. So you have a foot being the distance unit and then pounds being the force unit, so they get multiplied together, which is big because the more we increase the distance between our screw and this base here, the more that torque it actually like increases as a multiple of that distance. So the distance is more important than the force if we're going to kind of just make a quick tweak to fix this. So I've also decreased the distance here because there's going to be, as this walks out, as this screw kind of walks itself out and increases the angle here, we're going to get an X component force that is going to kind of open this up and pull everything out of whack from all the component parts. So if we decrease this distance, we have a smaller distance here for that torque to be, or that force to be applied through, changing the moment at this point here. So if we decrease this distance, first things first, that should kind of reduce how much this opens up. The other distance that we'd have to decrease would be this distance here. But we are limited by the fact that our foot and our screw need to miss a crossbar on my desk. So that is what makes this a little tricky. So the other option would be to add some different geometry here, and realistically we could probably do a combination of the fillet that I just had put on here and reducing these distances, these lengths here. So if I do a small, less awful looking fillet here, like a 0.75, now there's a lot more material where that torque is being applied through, and it should kind of grab everything nicely. So what will change is where my Quest 3 sits relative to my desk. Because maybe if I pull this camera off, let's see what happens. If I pull this camera off, it's going to freak out and not show anything. Okay, so I'll have to find a better way to illustrate that because I got a face detection thing running right now. But yeah, I'm pretty limited with how this will end up mating to the desk. So the more that we decrease this distance, you can imagine the top of my desk is sitting flush against this face here. If I make this shorter, now all of these features, this arm and where the Quest 3 actually sits, are actually rising relative to my desk. So these are going to sit much higher relative to the desk, which if I throw this back on my desk real quick, I can see like how that may look and kind of determine whether or not I hate that. And it actually may not be a problem because there is some interference with one of these controllers. Like the controller actually does hit the desk a little bit. So if I bring it up, it may clear the desk. The other option would be to pull this surface out so that the controller sits a little further off of the desk. But I kind of like the way that everything sits in plane. You know, actually, let's do that. I kind of like that. If we pull this surface out a little bit, so we can find our drawing here and edit this sketch. We have this set to be tangent to that line. So if we delete that relationship, and then we say that this distance, there's actually going to be a distance here of, let's just call it 1 for the time being. that should pull this away from our arm. I'm kind of okay with that. One thing that we can do as well, since this whole thing just kind of got shrunk down a little bit, is we can probably decrease the length of our screw, which would be good because I had to print the screw on its side because I was really worried about having, let me just pull this guy out of the threads here. One moment. The reason why I had to print the screw on its side is that I was worried that on the print bed, because there's a really small kind of surface area where the screw contacts the print bed, I was worried once it started getting to the top of the screw and started printing on the very tip that we'd run into the same issue that we're kind of running into with this bracket, where the print head is going to be extruding material on the top of this and applying a small force in the X direction as it prints, but that small force is now multiplied by this entire length here as it prints. So you can imagine the printer starting here, printing it all the way up vertically. This very tip is going to be more than likely a disaster for how this screw sits on the surface of the print bed, because now we're applying a whole lot of torque on that surface, and the second that this gets kind of unstuck, I don't have a better way to say that, the second that this gets unstuck from the surface of the print bed, the print's going to fail. And because the printer has no concept of the print quality, it's just following a set path with set parameters. So the more that we apply load that's not directly in this axis, the more likely we are to cause this thing to tip and snap off the print bed and kill our print. So what I did was I printed it like this, which whole lot more surface area. Their downside to that is that now our print quality along these grooves here, let me see if I can kind of show that well. The print quality on the threads themselves dramatically decreases because we're asking our printer to basically print diagonally and print a circular profile at the same time, which is really tough to capture with this kind of extrusion profile that it's doing. It's just taking filament and extruding it along a surface. So if we're not printing in one plane going vertically, and we're printing kind of like a cross plane doing this weird circular complex geometry, it will kind of fail. Not fail in the sense that this is unusable, because it clearly still engages correctly, and I'm actually kind of happy with how the threads engage on this, but it'll fail in the sense that like they're messy, and I had to kind of screw this in and really torque it through the first time, and because this is plastic, the friction actually will heat it up enough to kind of melt it and thread form it. It's probably a combination of the friction molding the plastic and also just like wear on the threads that kind of break them in. So it'll remove all the material that would otherwise clog the threads. But again, 3D printing threads is tricky. That's why people don't do it typically. They typically will take something like this base here, and just print a through hole and then tap it in post. So that's actually a process of cutting threads into that surface instead of printing them into the surface. So all of that is to say, if we decrease the distance between these two faces, this face and this face, like we just did, now our screw doesn't need to be as long. And if our screw is shorter, let's say we make it half the size, which is roughly what we'll have to do for this, that force that I was talking about that could cause this to snap off the print bed, or that moment, which is, remember, a product of the distance and the force, if we half our distance, we now half the moment on that surface. So we should be able to just print this vertically, which would be sweet. So I'm kind of happy, I think, with how that looks. what we're going to do now is go into our other components, and let's save this first. We're going to go into our foot here, and we're going to, actually no, let's just change the screw height first. So again, assuming that I made all of my parts correctly, we should just be able to go into this profile here, and oops, we just should be able to edit this feature and change this from 4 to, I think we dropped the other one down to 2.5. So, oh, we broke some stuff. So what was broken? What did we screw up? So it's something to do with this revolve. How did we define this? Ah, we didn't define this. So this guy actually needs to... Oh man, we really screwed that up. So let's just undo. Let's just close this thing. Don't save it. Discard changes in assembly, and then reopen it. So before we do anything crazy, let's define this profile, because I like the way that came out. Okay. So now that's fully constrained. So if I drop this height down and I say you're going to be 2.5 inches now, that should look the same. And it does. So we did our job. So now we fixed, let's hide this thing and also hide the sketch. Where is my sketch for that? It's in here. So our screw is now the right height, distance, and we will go back to our assembly and just see how this looks and save these guys, and then I should be able to just pull that down. So the last thing that we wanted to fix was the foot, and if I change this mating thing here, I have these parallel right now. So as you can see in our design, this foot should, hey, wait a minute, you're gonna not be concentric anymore. This foot should rotate around that face. And I did a poor job of, let me just make this guy parallel again. Parallel. I did a poor job of setting this thing to have kind of like a snap in interface. So let's try that again. If I can probably kind of illustrate this here. So what I did was I left about 5 thou of overlap between this circular profile, the socket that the foot has designed into it, and the screw itself. So also just like some inadequacies in the print of the screw, you can kind of see how it's deformed there. Again, it's because I printed it on its side like this. It's not a perfect circle, so we're gonna see when we reprint this if those issues go away. But let's open the foot and increase the interference between those two parts. So if I edit the sketch, I have this set at 10 thou. Oh, 5 thou. Okay, so let's do 15 thou. And actually, we can be pretty generous with this, I think. So what this is doing is actually increasing the amount of like circle, for lack of a better term. We're increasing the amount of overlap there is between the socket of this foot and the ball of this component here. So what will end up happening is I'll actually have to place it on here. It's going to interfere, and then I should have to just push it down and have it snap into place so that these will become one integrated component. So the more that I make this interfere, the more I'll have to press this into place and have it snap onto the ball. And ideally, the more well constrained this foot is. So one other thing that I might want to do is round off this profile a bit, because if it's a little rounded off, that I can actually increase that interference more, and it's not going to be a sharp edge that'll dig into the surface of the ball. So let's try that. Let's round off this profile just a tiny bit. Let's do like 0.025. See what this looks like. That might be a little too much. Let's try 0.015. So if I round that off, I'm kind of okay with that. So I should be able to now actually increase this to 0.075, something like that. And let's save this and go back to the cross section, the section view of our assembly. Oops. And if we section view this thing from here, now you can see, hopefully, that when we install this foot onto this ball, it's actually going to have to, there's going to be interference along this profile, like right here. It's going to have to kind of like snap over this edge. So if I think the best way for me to illustrate this would be to take this guy. Oh, we're cutting this at like a weird angle. And then if I measure the distance between these two surfaces, and I set this to minimum distance, yeah, we'll have, what's our y? So our x, y, and z here. So that's 2 thou interference, is what it's telling me right now. Let's just go center to center. Nope, that's not it. Also not it. Do we want to trust our gut here? That's the question of the hour. Do we want to trust our gut? Maybe if I just measure this in here, measure these two profiles against each other, and do minimum distance. Actually, maximum distance. I say we trust our gut. What's the worst that can happen, right? So one big thing, again, with how this shortening this distance here, just shortening the length of the screw, is will dramatically reduce how much this thing ends up walking itself out as well. And another way we can do that is by increasing this thickness here, which I actually really want to do. So this is mirrored. That's how I designed it initially, which at the time made sense. Where's that first mirror? Maybe I can just edit this guy and see what happens. So let's make this like 3/4 of an inch. Ah, it's not mirrored. Lovely. It's not mirrored. So this is gonna be hidden. You'll never see how thick this thing is when it's being installed. So, or when it's actually installed. So what we can do is kind of make this a little bit bigger. Now we have more kind of cylinder on cylinder. You imagine the screw is a cylinder, and then these threads are a cylinder as well, and they're concentric. So now there's more surface area of our threads to kind of constrain the screw from wobbling back and forth or walking out in these threads. So if I grow this thickness here, there's less room for this thing to kind of like or there's more surface area constraining the screw so that it can't kind of like wobble back and forth and bend. Um, so I think actually that kind of sums up everything that I wanted to modify in this. Let's just go back to our assembly and make sure that there's nothing glaringly obvious that's wrong with this. So we increased this distance here. We increased or decreased rather the distance between our little arms here that grab the desk. I'm almost wondering, because it is kind of a tight fit on my desk with the crossbar, I'm almost wondering if I want to grow this length to a little more. And you know what? Yeah, we're gonna do that. So one problem that I'm noticing is that even though I accounted for the distance of the crossbar isn't evenly spaced along my entire desk. So if I want to mount this to a different location, it's going to be a little tricky. So I can just increase this distance, and then that'll pull the foot away from this surface here. So the foot will actually sit like, let me get this in frame. Let me see here. So the foot will actually sit like out here as opposed to right here. And then there's more distance between these two faces, this face and the edge of the foot, so that we can miss that crossbar more reliably. And I think with the modifications that we made to make this a little bit stronger, we can do that. So let's find our initial, I think that was the first sketch that we had. Yeah. Let's find our initial sketch and make this 3 inches. I think another ½ an inch would be more than we'd need for that. So now, when we mount it to our desk, we are very certain that we're going to miss that crossbar. An extra ½ inch will definitely be enough. So, ultimately, kind of happy with how that this initial run ended up coming out. There's some things that I'll fix about how I slice this and place it on the printer. And oops, then we should be rocking and rolling, and this will be a completed design. So yeah, I guess I'll get all that going, and then we'll print it and see how it comes out, and figure out if there's any other business that we want to take care of from there. But cool. Thank you guys for watching, and we'll continue this until we inevitably give up. So, all right, see you later.